So welcome students. So in this question, you're given two statements. Statement 1 is, so when a bullet is fired from a gun, it hits the target and the observer is so placed such that he hears the sound of the shot and the sound of the bullet hitting the target at the same time. So if that is so, what is the locus of this observer? Given that this locus is a hyperbola, you have to check whether it is right or wrong. And the second statement is, if the difference between the distances of a point from two given points is constant, which is less than the distance between the given points, then the locus is a hyperbola. So S2 is obviously right. S2 is the basic definition of hyperbola. The hyperbola is nothing but the locus of points which maintain a constant difference with respect to two given points. If a point P is such that SP minus S dash P, the difference between the distances, the magnitude of difference between the distances is constant, which is less than the distance between S and S dash, then the locus is a hyperbola. So there is no doubt about it, the second statement is true. So you just need to see whether the situation in the first statement converts itself into this statement mathematically. Now, according to the given information, the observer hears this sound, the crack of the gun and the thud of the bullet hitting the target at the same time. That means the time taken for this sound to reach this guy is same as the time taken for the bullet to go from the gun to the target and reach back. So what is the, let us write this equation, let us write this in equation form. So this distance, let us take this as P, let us take this as S, let us take this as S dash. So what is SP? What is SP? So what is this distance? Let this be D1. So what is the time taken? So let us say that after a time T, this guy hears this sound as well as this sound. So according to the condition, so velocity of the bullet in the velocity of sound is Vs, velocity of the bullet is Vb. Now if this distance is T1, so what is the time taken by this sound to go from this point to this point? So Sp, the distance is equal to which is D1 is equal to, so velocity of sound into time. Now it took the same time for the bullet to go from here to here and come back here. So what is the time taken for the bullet to go from SS dash? Time taken is distance by speed, that is distance. So let this be D2, let this be D3. So D3 by velocity of bullet, because from here to here the bullet has gone, and time taken to travel from S dash to P is equal to D2 by the velocity of sound, because sound has traveled from here to here. Now according to the given condition, this time is same as the sum of these two times. So D1 by velocity of sound is the time taken directly, and the sum of these two times is also equal to T. So D1 by velocity of sound is equal to D2 by velocity of sound plus D3 by velocity of the bullet. So this implies D1 minus D2 by velocity of sound is equal to D3 by velocity of bullet. This implies D1 minus D2 is equal to D3 times velocity of sound by velocity of bullet. And in this case, as the observer is moving, D1 and D2 are changing, but D3 is a constant. So if D3 is a constant, D3 into Vs by Vb is also a constant. So D1 minus D2, the difference between these two distances should be constant, and Vs by Vb as given from the condition is less than 1. So Vs by Vb is less than 1. So D3 into Vs by Vb, so this length is less than D3. That is less than the distance between these 2 points. less than the distance between these 2 points. Hence, d1 minus d2 is equal to constant which is less than the distance between 2 given points is a hyperbola. That means the locus of this observer is a hyperbola. So first statement is also true, second statement is also true, and second statement is the correct explanation for the first statement. Thank you.